Hello, my name is Sergio Alfredo Minahueche, and now I'm going to talk about my key activity that was about the rocket balloon. So for my introduction, first, the justification. The reason why I chose this topic is because I wanted to see how the forces could work when an object has only one way out, just like rockets, but in a simpler concept with materials that I could get easily and do it at home. The theoretical framework. Well, first, my objective and my hypotheses were that how the volume of the balloon and the air contained, and it affects the time it takes the balloon to get to the other side. Well, my hypothesis was that the greater the volume of the balloon, the greater the velocity of the balloon, and the faster the balloon was going to get to the other side of the rope. For my experimental arrangement, I did put the object or the balloon hanging from one end of the rope of yarn with two pieces, or in this case, one piece of straw taped to the balloon and release it from different volumes of the balloon to see the difference in time that the was needed to cover to get to the other side. Methodology. Well, the principal variables that I consider were first independent, the rope's length, the angle of inclination of the balloon, and its volume. For the dependent, the time and the velocity of the balloon. For the control variables, the mass of the balloon and the air resistance. And here, as you can see, is a photo of the experiment after taking place with everything of the materials that now I'm going to talk about. So the materials that I used for this experiment were first, a rope of yarn, second, a balloon, third, a pair of scissors, fourth, a straw, fifth, a timer, sixth, measuring tape, and last, the tape to put everything together. The results, well, as you can see in this table, from the different volumes recorded, I used a normal final velocity formula, taking the mass, the volume, the time it took to the other place to get the final velocity. And as you can see, as I said, depending on the bigger the volume, the faster it was to get to the other side. And as you can see here, it was a really small volume and it took, it was slower, so it took more time. Therefore, the final velocity was slower. And here, as you can see, is the graph of, of the table that I just showed to you. And here, as you can see, is shown all the variables, all the spikes, and how it was very fluctuating because of external variables that I didn't was well to consider that I'm going to mention in the last part of this presentation. So in conclusion, I made use in this practice. I made use of a balloon as and a rope of yarn to analyze the time that it would take the balloon to reach the other side, depending on its different volumes. And based on the results record, I can say that after the object was released, with each of the different volumes documented, it has been proved that the greater the volume of the balloon, the faster it is, therefore it takes less time to reach the other side. Now, the main limitations faced were that the object, when released, it was unfortunately not from the same angles all the time because of, well, human error that we all have, and that this usually is done with machines. So, and also sometimes the end where the air was pushed out was stick to my hands, so that took some air out before it could actually launch. But the future solutions for this experiment are that I could use a stable, place to put the balloon so that each time is from the same angle, and then just release it, maybe with a lever or a button, so that it can get all the time the same way to the other side. And here is a photo of the experiment taking place. Thank you for your attention.